The way we build our world is constantly evolving, isn't it? You see it everywhere, this drive for smarter, faster, more efficient construction.
Definitely.
And that's really why we're diving in today. You're the kind of person who wants to understand these shifts, to, grasp what's important without getting totally bogged down in endless reports.
Absolutely. And you've given us two really interesting pieces to explore this time. First, there's a 2023 systematic review by Kendall and colleagues. It focuses specifically on how geographic information systems, or GIS, are being used in construction.
Okay, GIS.
And then we have, well, a broader perspective from a Boston Consulting Group report. It's a bit older, from 2016, but it looks at the wider impact of digital technologies in engineering and construction, with building information modeling, or BIM, really taking center stage there.
Got it. So GIS focus and then a broader digital view with BIM. Our goal today then is, well, pretty straightforward. Unpack these two sources, get a clear handle on how digital tools like GIS and BIM are reshaping construction. Think of this as your shortcut, really, to getting up to speed on these technologies and what they might mean. So let's jump right in with that Kindle review on GIS.
Let's do it. So the review kicks off by calling GIS a fast-emerging green area of a digital revolution in construction.
Green area.
Yeah.
That sounds promising.
It does. It immediately signals that, look, this isn't some, tiny niche technology. It's a growing, significant part of how things are getting done.
Right. Green as in growing adoption, I guess.
Yeah.
So for someone who might be new to this, in the construction world specifically, what is GIS fundamentally?
Fundamentally, okay. GIS is essentially a framework for working with location-based info. It lets you capture it, store it, process it, and then, crucially, visualize it on geo-referenced maps.
Maps with data layered on top.
Exactly. And what's really compelling are the benefits the review points to, drawing from earlier research. Things like cutting costs, speeding up project completion, boosting productivity.
Okay, those are the big three everyone wants. Lower costs, faster builds, more output.
Precisely. Outcomes everyone in construction is chasing.
Definitely. So according to this 2023 review, where are we actually seeing GIS pop up on construction projects? Where is it making a tangible difference?
Okay, so they identified four main application areas. First was spatial planning and design. That accounted for about 27% of the uses they studied.
Planning and design, like site selection.
Yeah, things like choosing the best site, assessing potential environmental impacts, just generally figuring out the optimal layout from a geographical standpoint. But what's interesting here is they found a lack of application in earthwork operations projects.
Really? That
Yeah.
seems odd. You'd think mapping and terrain data would be huge for earthworks.
It does seem counterintuitive, yeah. But that's what they found. Anyway, the most common area
Go on.
was construction task management. That was the biggest chunk, 48%.
Task management. So the day-to-day stuff.
Exactly. Tracking progress, managing where resources are like equipment, people coordinating all the different activities happening across a site. The review noted this was particularly common in building projects. It's about bringing that spatial intelligence to the actual execution.
Right. So GIS is helping keep building projects on track and, well, hopefully better managed. What about spotting problems? Dealing with issues that crop up during construction?
Okay, that falls under defect detection. But surprisingly, this was the least common application they found. Only 5%.
Wow, just 5%.
Yeah. And what's quite notable is they found 0 instances of GIS being used for defect detection in railway, landscape, or heavy engineering projects. None at all.
That feels like a missed opportunity, doesn't it? Using
Yeah.
location data to improve quality control there.
It really does suggest that, yeah. Catching issues early, as you know, can save enormous amounts of time and money later.
For sure. Okay, and the fourth main application area.
That was safety monitoring. Made up about 20% of the applications they looked at.
Safety. How does GIS help there?
Well, think about identifying potentially hazardous zones on a site. Maybe monitoring worker locations in relation to those zones, or even planning efficient emergency response routes.
Makes sense.
But similar to defect detection, they noted an absence of its use for safety monitoring in railway and landscape construction projects.
Okay, so we're seeing GIS being picked up, but definitely more in some areas than others, and clear room for growth, especially in certain project types and for things like defect detection and safety. Now, how does GIS actually talk to all the other digital tools out there? How does it fit into that bigger digital puzzle in construction?
Right, this is where their findings on integration patterns become really important. RQ2 in the paper, they found the most frequent data flow, almost half at 48%. was from devices or, standard software interfaces directly into the GIS system.
So like data coming straight from a GPS unit used by a surveyor.
Exactly. Or project managers inputting site info through a basic computer form. That data feeds the GIS.
Okay, getting that real-world, location-specific data into the system. What about the big connection we always hear about BIM and GIS?
Ah, yes, the BIM GIS link. Hugely important. The review found that about 13% of data exchange happened directly between BIM and GIS systems.
Only 13% directly.
Directly, yes. But what's maybe even more telling is that a much bigger slice, 39%, involved data flowing from both BIM and GIS into some kind of customized system.
Ah, so intermediary platforms or custom solutions are bridging the gap quite often.
It really highlights the need for those, yeah. Helping these two powerful but different tools work together effectively. They also mentioned, by the way, that ArcGIS was the most common software involved in these integrations.
ArcGIS, okay. That's a big name in the GIS world. Did the review give any concrete examples of how this integration actually works on a project?
They did, yeah. They pointed to work by Pedamani and colleagues back in 2019. They took data from scheduling software and CAD software, the detailed design drawings, and pulled it into GIS to create 4D visualizations.
40, so 3D plus time.
Exactly. Imagine watching the construction project unfold spatially over time, seeing the sequence. Another example was Karan and Rizari in 2015. They used something called semantic web services, basically a way for different systems to understand the meaning of data, not just the raw bits, to get data from Revit, which is a major BIM tool, and ArcGIS working together during pre-construction planning.
Those 4D models, wow, they sound incredibly useful for spotting potential clashes or just visualizing complex schedules. But look, it can't all be plain sailing with GIS adoption, surely. What did the review say were the main roadblocks?
No, definitely not all easy. The review really hammered home one major hurdle: the lack of interoperability.
Interoperability, getting different systems to talk to each other.
Precisely. Between different or heterogeneous systems, they actually called this the crux impediment, the main thing holding back wider, smoother adoption. It's that challenge of getting different software, different data formats to just connect seamlessly.
Yeah, that sounds familiar. It's a headache in lots of digital areas, not just construction. Anything else making GIS adoption tough?
They also pointed to the complexity of GIS data structure itself. Setting up and analyzing the databases often needs specialized knowledge. They cited Liu and others from 2017 on this point.
Yeah.
It's not always intuitive for construction folks who haven't had specific GIS training.
Right. So you need the expertise and the systems need to actually play nice together. Looking forward then, what did Akindele and the team suggest for future research? Where should things go next with GIS in construction?
They flagged several promising avenues. One was pushing for further integration between CIM and BIM.
City information modeling.
That's the one. Taking that broader urban level view, integrating that with BIM for designing sustainable smart cities. That's a pretty ambitious forward-looking goal.
It certainly is. Very big picture. What else?
They also suggested developing more unified kind of embedded systems. The idea is to make integrating different models much smoother, especially for managing those day-to-day construction tasks we talked about. Imagine just having all the spatial and design info together in one place seamlessly.
Yeah, a single pane of glass approach. That would be ideal.
And finally, they see huge potential in combining IoT, the Internet of Things, all those connected sensors and devices with GIS, and then layering on advanced analytical models like machine learning, perhaps, to really boost both defect detection and safety monitoring.
Okay, so it's all pointing towards deeper integration, more unified and user-friendly systems, and really leveraging all that data coming off connected devices on site. That gives us a really solid picture of GIS. Now let's pivot to that BCG report. This one takes a broader sweep, right? Looking at digitalization across the board in engineering and construction, with BIM sort of at the core.
Exactly. The BCG report, though, from 2016, sets the scene by highlighting the sheer size of the E&C industry, about $10 trillion globally per year back then, but also pointing out how, frankly, slow it's been in adopting new tech compared to other sectors.
Yeah, I've heard that before. Kind of lags behind manufacturing or aerospace.
Right, and they specifically call out the stagnation of labor productivity in construction as a major red flag.
Stagnant productivity in a $10 trillion industry. Yeah, that screams opportunity for disruption, or at least serious improvement. So how does BCG see digitalization with BIM playing a key role addressing this?
They position digitalization as the key transformative force, and they're pretty bullish on the potential benefits. They estimated almost a 20% reduction in the total life cycle costs of projects.
Wow, 20% across the whole life cycle. That's huge.
It is. Plus, significant improvements in project completion times, construction quality, and safety on site. That kind of impact. Yeah, potentially game-changing for the industry.
A 20% cost reduction alone would get anyone's attention. So what does this digital setup, this architecture actually look like in E&C, according to BCG? What are the building blocks?
They lay out a kind of multi-layered structure. You can think of it starting at the ground level with sensors and equipment.
Okay, the physical stuff.
Right. Things like embedded sensors and materials or on machinery, drones, UAVs for surveys and monitoring, intelligent equipment that can operate semi-autonomously, 3D scanners capturing reality, additive manufacturing, 3D printing, and then location tech like GPS and RFID tags for tracking.
So all the tech that's generating data or interacting with the physical site. Got it. What's the next layer up?
That's what they call the digital physical integration layer. This is where the data from those sensors and equipment gets processed and used. It includes things like mobile interfaces, tablets, phones for accessing info out on site,
Makes sense.
augmented and virtual reality for visualization, overlaying digital models onto the real world or immersing yourself in the design, simulation tools for testing, and big data analytics to actually make sense of all the information being collected.
Okay, so this layer bridges the physical world and the digital information, making it usable. And what sits at the very heart of it all?
The software platform and control layer. And right there in the middle, according to BCG, is BIM in the cloud. This is the central hub. It's where the digital project models live, where all the information is managed and shared, and where the whole project is digitally controlled and coordinated.
BIM as the central brain, basically.
Pretty much.
Yeah.
And then wrapping around all that, you have the various user interfaces and specific applications that let different people, designers, engineers, project managers, workers on site, interact with the system in ways that make sense for their jobs.
Okay, that paints a pretty clear picture. A layered digital ecosystem for E&C. So how did BCG see these technologies being applied across the different project stages? From the initial idea through to running the finished building.
Yeah, they broke it down nicely across the value chain. Design and engineering first, then construction, and finally operations and maintenance.
Makes sense. Let's start with design and engineering.
Okay, here they highlight things like using BIM for parallel and more robust design. It helps different disciplines collaborate better, catch clashes early. They also talk about virtual migration of physical structures. Think using 3D scanning or drone mapping to create an accurate digital twin of an existing building before you start a renovation.
Ah, and that ties directly back to the spatial data aspect of GIS, right? Mapping what's already there.
Exactly. A really clear link. You need that accurate spatial starting point. BCG also mentioned data-driven design, using big data analytics to inform decisions. Again, you can see GIS feeding into that, analyzing spatial factors like, site conditions or even local demographics.
Right, using data to optimize the design itself.
And simulation and rapid prototyping too.
Yeah.
Using digital visualizations may be enhanced by GIS for context, and even 3D printed models to test ideas much faster. They mentioned how the Sagrada Familia in Barcelona uses 3D printing, which is just a fantastic illustration.
Wow, using tech like that on such an iconic, long-running project. Amazing. Okay, moving into the actual construction phase. What did BCG see as the big digital opportunities there?
Well, number one is real-time data sharing and integration, using that cloud-based BIM platform, which, echoes what Akindle found about data flow being critical.
That central source of truth again.
Right. Then there's data-driven planning using big data, maybe combined with RFID tags, to track exactly where materials and equipment are on site in real time. And new fabrication methods, things like modular construction, prefabrication off-site, which digital tools make much easier to manage.
Improves efficiency, quality control.
Definitely. And then there's the really futuristic stuff, automated and autonomous construction. They gave the example of Komatsu's autonomous bulldozers, guided by drone surveys. That's digital control meeting heavy machinery.
Autonomous bulldozers. Feels like sci-fi, but it's happening. What about just keeping tabs on the build process itself? Monitoring.
Crucial area. Rigorous monitoring, using digital measuring tools, 3D laser scanning to compare the actual built structure against the BIM model, checking for accuracy, and using drones for regular site progress surveys. They cited the Washington Nationals Stadium project.
The baseball stadium.
Yeah. Apparently, using BIM to keep everyone in the supply chain on the same page resulted in incredibly few requests for design clarification compared to traditional methods. It just shows the power of having that shared, up-to-date digital model.
So digitalization isn't just about fancy robots, it's also about improving those fundamental processes of managing and checking the work. Okay, finally, the operations phase. Construction's done. How does digital keep adding value?
Well, BIM-enhanced operations and maintenance is a huge one. Having that detailed digital model as a living record of the building makes maintaining it, planning upgrades, finding information just much more efficient.
Like a digital owner's manual.
Kind of, yeah, but much more dynamic. BCG mentioned NTT facilities in Japan cutting their O&M costs by 20% using BIM integrated with their facility management systems. That's significant.
Yeah. 20% savings on running costs year after year. Yeah, that adds up.
Definitely. They also talk about virtual handover, using the digital model to train the people who will actually run the building, and smart O&M using augmented reality. Imagine pointing a tablet at a pipe and seeing its maintenance history overlaid. Companies like BDS Vercon and IBM were mentioned there.
AR for maintenance.
Cool. And finally, condition monitoring and predictive maintenance, using sensors, cameras, 3D scanners embedded in the structure to constantly check its health and predict problems before they happen. They mentioned a bridge monitoring device developed at Rutgers University as an example for infrastructure.
So the BIM model isn't just for building it, it's a valuable asset for the entire life of the building or bridge or whatever it is. Even helps plan the next renovation or eventual takedown. BCG really paints a compelling picture, don't they?
They absolutely do. The potential across the whole value chain is massive. But they are careful to add a dose of reality, noting that while these success stories exist, getting widespread adoption across what's often a very fragmented E&C industry, well, that's still very much a work in progress.
Right. Which brings us neatly to trying to connect these two sources. We had the deep dive into GIS from Ackendell, then this broader digitalization picture from BCG with BIM at its heart. How do they mesh together? How should we think about them in relation to each other?
Yeah, that's the key synthesis, isn't it? The BCG report really emphasizes that central software platform and control layer with BIM as the hub, the project's brain.
Okay.
What the Aikendale review on GIS shows us, I think, is how a powerful specialist tool like GIS plugs into that ecosystem, how it integrates with the central BIM hub, and sometimes with other platforms too, to really enhance specific tasks that have that crucial spatial dimension.
So you could almost think of GIS as like a vital app or plugin within the larger digital operating system that BIM helps manage.
That's actually a pretty good analogy, yeah. BIM provides the overarching model, the data environment, the coordination framework. GIS brings its unique spatial analysis and visualization power to specific problems within that framework. Site planning, logistics, environmental checks, progress tracking based on location.
Okay, that makes sense. And both sources really seem to stress the importance of integrating data, didn't they?
Absolutely. Akindo gave us that detailed look at the data pathways, especially the significant, though sometimes indirect, exchange between BIM and GIS. BCG, taking the wider view, showed how pulling all this data together from BIM, from GIS, from sensors, from drones, provides those incredibly valuable insights for making smarter decisions at every single stage: design, build, operate.
Better decisions based on better, more integrated data. But those interoperability problems that Akindele called the crux impediment, they must be a major barrier to achieving that seamless, integrated vision that BCG describes.
Without a doubt. That difficulty in getting different systems, different data formats to talk to each other smoothly, it directly hinders the kind of efficient flowing digital workflows that BCG envisions. If data can't move easily between, say, your design software, your GIS, your
Yeah.
project management tool, and the equipment on site, you lose a massive amount of the potential benefit.
So fixing that interoperability puzzle is critical to actually unlocking the full potential BCG is talking about.
Totally critical. It's probably the key technical challenge the industry needs to solve to really accelerate this digital transformation.
And thinking back to Akindle's suggestions for the future, things like deeper CIM and BIM integration for smart cities, developing more unified embedded systems, those sound like potential pathways to actually overcoming these current roadblocks, right? They seem aimed squarely at enabling the kind of transformation BCG outlines.
Exactly. Those future directions aren't just academic exercises. They represent potential solutions to the very real integration and usability challenges holding things back now. Achieving that tighter, more seamless integration between specialist tools like GIS and the core BIM platforms, plus bringing in IoT and AI more effectively, That's likely where the next big leaps in construction productivity and efficiency will come from.
Okay, so let's try and wrap this up. Summing up our deep dive into these two really insightful documents, it seems crystal clear that GIS and BIM are, well, foundational digital technologies that are genuinely reshaping the construction industry.
No question. They offer huge potential for boosting efficiency, productivity, safety, and also, importantly, the sustainability of everything we build.
We saw from Akindel that GIS has carved out clear roles in spatial planning, task management, defect detection, and safety monitoring, although, its uptake isn't uniform across the board yet.
And we saw how it integrates, sometimes directly, sometimes via custom solutions, with other key systems, especially BIM, to create these more powerful, data-rich digital workflows.
But we absolutely have to acknowledge the challenges that remain. That interoperability issue is a big one, a major hurdle. And the need for specialized skills to really leverage GIS effectively is also a factor.
True. But the good news is there's a lot of research and development focused specifically on tackling those limitations, on making these systems work together better and be easier to use, pushing the boundaries.
Which leads us, I think, to a final thought for you, the listener. Considering how complex construction projects are getting and how much emphasis there is now on sustainability, just imagine, what could a truly seamless integration of GIS and BIM actually unlock?
Yeah, think beyond just how we build. How might it fundamentally change how we plan our cities, design our infrastructure, manage our entire built environment for a future that needs to be more resilient, more sustainable?
It really prompts you to think about the downstream effects, doesn't it? It's
Yeah.
maybe worth keeping an eye on those developments in data interoperability and looking out for real-world examples of how these integrated digital solutions are starting to deliver on that transformative promise.